For 7 years we'd been preparing, and suddenly, for a period of several months, we were overwhelmed with a flood of discoveries, one after the other, many every day.
None of the NASA missions has explored as many planets, rings, and satellites, or has offered as many new understandings of the outer planets as Voyagers 1 and 2 have, since they launched in 1977. The Voyager mission team, led by Dr. Edward C. Stone, received the Collier Trophy in 1981 for its groundbreaking flyby of Saturn, marking a significant achievement in solar system exploration. The team also garnered the Dr. Robert H. Goddard Memorial Trophy twice for encounters with Jupiter and Saturn. The Voyager spacecraft's scientific impact was remarkable as it explored Uranus and Neptune before venturing into the uncharted territories of interstellar space. These spacecraft took advantage of a rare alignment of Jupiter, Saturn, Uranus, and Neptune, allowing them to conduct a multi-planet tour and further exploration of 48 moons and the unique systems of rings and magnetic fields that each planet has with minimal fuel requirements. Voyager represents a monumental endeavor in planetary exploration. Initially conceived as a grand tour of the solar system encompassing Jupiter to Pluto, the mission was later scaled down to the Mariner Jupiter-Saturn mission before being rebranded as Voyager shortly before launch. It stands as NASA's most extensive planetary expedition, having explored 4 planets, discovered 22 moons, and returned a wealth of photographic images unparalleled in space exploration. Join us as we explore the discoveries of Voyager 1 and 2 on their journey through the outer reaches of our solar system. What hidden truths did it reveal? How did this mission redefine our understanding of the cosmos? What legacy does it leave for future generations of explorers? Prepare for a journey through time and space as we reveal the mysteries of the Voyager missions and their profound influence on humanity's quest for discovery. Less than 2 weeks after its launch on September 5, 1977, Voyager 1 achieved its first milestone, capturing the first image taken by a spacecraft that included both the Earth and Moon in the same frame.
So as Voyager 1 was leaving, it took this amazing picture. I want to show you. Very historic. First time that we saw the Earth and the Moon together.
Once they departed from Earth, Voyager 1 and 2 embarked on distinct trajectories through space. Due to its shorter route, Voyager 1 reached Jupiter and Saturn sooner than Voyager 2. This allowed Voyager 1 to conduct pioneering observations of these gas giants before its counterpart, contributing valuable data to our understanding of the outer solar system. On January 30th, 1979, Voyager 1 started taking pictures every 96 seconds for 100 hours to generate a color time-lapse, a movie depicting 10 rotations of Jupiter. Then, on February 10th, 1979, the spacecraft entered the Jovian Moon system. By early March 5th, 1979, it had its closest encounter with Jupiter at 12:05 a.m. Universal Time at a range of about 349,000 kilometers or 217,000 miles from the planet. By this time, Voyager 1 had just discovered Jupiter's ring, a thin band of silica and carbon dust less than 30 kilometers or 19 miles thick. During its Jupiter encounter, Voyager 1 measured the planet's atmospheric composition. Jupiter's atmosphere displayed a colorful array of alternating zones. Cold, bright zones dominated by ammonia ice crystals existed at higher altitudes. Warmer, dark belts of solid sulfurous particles swirled in the lower atmosphere. Voyager's cameras gave scientists incredible close-up views of the Great Red Spot, a giant storm raging in Jupiter's atmosphere for over 3 centuries. Voyager 2 started transmitting images of Jupiter for time-lapse movies of atmospheric circulation on April 24, 1979. As Voyager 2 approached Jupiter, the massive planet that fascinated Galileo, it felt a strong shock from the solar wind hitting Jupiter's magnetic field. Jupiter, named after the Roman god Jove, is a massive ball of swirling gases, big enough to fit over 1,300 Earths. On July 9th of the same year, it had its closest encounter with Jupiter at 22:29 Universal Time, at a range of about 645,000 kilometers or 400,785 miles from the planet. Voyager 2 arrived at Jupiter just 4 months after Voyager 1, and its mission builds upon its earlier discoveries. The spacecraft captures images that show the dynamic nature of Jupiter's atmosphere. It discovered that the appearance of the Great Red Spot had already changed. It looked much more uniform compared to Voyager 1's observations. The spacecraft also achieved greater precision in measuring wind speeds, creating a detailed map of how atmospheric gases circulated the planet. Its contributions extended further, providing the first lightning detection on Jupiter and analyzing the upper atmosphere's temperature regulation and the chemical processes behind auroras. These observations confirm that Jupiter's characteristic bands and spots are not static features, but swirling gas flows encompassing the entire planet, resolving a scientific debate about their nature. Additionally, Voyager 2 captures more detailed images of Jupiter's faint rings, revealing them to be composed of tiny dust particles resembling a thin haze of ash and smoke. Voyager 1 also took detailed images of Jupiter's moons, including Amalthea, Io, Europa, Ganymede, and Callisto. Its exploration of Jupiter also included the discovery of 2 new moons, Thebe and Metis. Months later, Voyager 2 flew by Jupiter's 4 largest moons, much closer than Voyager 1. It took much more detailed information of every moon's surface that was first observed by Voyager 1. Callisto, covered in craters; Ganymede, marked by icy grooves; Europa, smooth and icy; and Io, glowing a reddish-orange due to sulfur. Voyager 2 also discovered a previously unknown moon, later named Adrastea, orbiting Jupiter just outside its rings. As Voyager 2 approached Io, scientists observed an object unlike anything they had ever seen. Scientists need to understand what they are looking at. Only when Voyager captures a navigation image while flying by Io does engineer Linda Morabito notice a large plume extending from the edge of this little moon. Io surprised scientists with its 9 active volcanoes, the first discovered beyond Earth and Venus. Erupting geysers of hot, sulfurous gas reach high heights, capable of impacting passing satellites, revealing it as the most volcanically active body in the solar system.
The 2 Voyagers took more than 33,000 images of Jupiter and its major moons. What these images and the other science results revealed was an exotic system that was not only vast, but beautiful, and almost beyond imagining.
Boasts 100 times Earth's volcanic activity, despite being just a tiny moon orbiting this giant planet. Dr. Edward Stone, Voyager's lead project scientist, considers the revelation of Io's volcanoes a significant advancement, prompting a reassessment of scientific perspectives on the evolution of small moons in the outer solar system. Jupiter could be considered a miniature solar system with at least 16 moons discovered during the Voyager program and 95 moons at the time of this recording. It is also important to note that even though the Galileo and Cassini missions would bring more advanced cameras to Jupiter, they didn't fly as close as the Voyager spacecraft. To this day, Voyager's images are still among the highest resolution images ever taken of Jupiter's atmosphere. However, pictures from the Juno space probe rival even Voyager's best pictures. After a 6-month exploration of Jupiter, the Voyager spacecraft received a gravitational boost from the giant planet and set their course for Saturn. Voyager 1 completed an initial course correction on April 9, 1979, in preparation for its meeting with Saturn. A second correction on October 10, 1979, ensured that the spacecraft would not hit Saturn's moon Titan during its flyby of the Saturn system. Voyager 1's closest approach to Saturn was at 23:46 Universal Time on November 12, 1980, at 126,000 kilometers or 78,000 miles. Following a course correction, 2 hours after its closest approach to Jupiter, Voyager 2 sped to Saturn. Its trajectory was determined to a large degree by a decision made in January 1981 to try to send the specific spacecraft to Uranus and Neptune later in the decade. Voyager 2's encounter with Saturn began on August 22, 1981, 2 years after leaving the Jovian system, and included imaging the moon Iapetus. The closest encounter of Voyager 2 to Saturn was at 1:21 Universal Time on August 26, 1981, at a range of about 101,000 kilometers or 63,000 miles. Voyager 1 found a complex ring system with thousands of bands and shepherding satellites that help maintain the ring structure. Pioneer 11 discovered the F-ring the previous year, which exhibits a braided pattern caused by 2 shepherd moons orbiting around it. A new ring, the G-ring, was also discovered. These tiny moons orbit at the edges of the planet's rings or in the gaps between them. Their gravitational pull keeps the ring's icy particles in place by herding them back into each ring, preventing the system from dissipating into space. During the encounter with Voyager 2, the spacecraft provided more detailed images of the ring, spokes, and kinks, the F-ring, and its shepherding moons. They found that Saturn's A-ring was perhaps only about 300 meters, 980 feet thick. These rings consist of many particles, varying from specks to larger objects comparable to houses. These particles interact by colliding with each other within the rings, creating distinct grooves. These grooves form due to the continuous disruption caused by satellites orbiting amidst the smaller ring particles. The instruments carried by Voyager 1 discovered that Saturn's atmosphere is a massive, frigid sphere primarily composed of hydrogen, with about 7% helium, which is different from Jupiter's atmosphere. Saturn completes a full planetary rotation at precisely 10 hours and 39.4 minutes. Through the Coriolis effect, this fast rotation affects wind speeds and, in turn, massive storms, which reach an astonishing 1,770 kilometers per hour or 1,100 miles per hour. Voyager 1 also observes that Saturn's atmosphere has many low-contrast cloud features and a circulation pattern different from Jupiter's. During its flyby of Saturn, Voyager 1 also captured images of its moons, including Titan, Mimas, Enceladus, Tethys, Dione, and Rhea, revealing that these moons are primarily composed of water ice, while Voyager 2 photographed Saturn's moons, Hyperion, Enceladus, Tethys, Phoebe, Helene, Telesto, and Calypso during its mission, further expanding our understanding of these celestial bodies. Certainly, one of the more exciting discoveries at Saturn was the atmosphere of Titan. It's an atmosphere that is mainly nitrogen, like that here on Earth, but which contains methane, so that the photochemistry going on there today may resemble very strongly that which occurred here on Earth billions of years ago before life evolved. Titan, which Voyager 1 passed at a range of 4,000 kilometers or 2,500 miles, was found to have a thick atmosphere composed of 90% nitrogen, with a surface pressure of 1.5 bars, or 50% stronger than Earth's sea level pressure, and a temperature of negative 180 degrees Celsius, or negative 292 degrees Fahrenheit. The atmospheric data suggested that Titan might be the first body in the solar system, apart from Earth, where liquid might exist on the surface. After a close-up view of Titan by Voyager 1, the spacecraft was not directed to Uranus and Neptune because of the specific requirements for the Titan flyby. Voyager 1 was propelled out of the plane of the solar system and started traveling towards interstellar space, while Voyager 2 continued its journey towards Uranus. To this day, Voyager 2 is the only spacecraft to have explored Uranus up close, flying past the planet in January 1986. Voyager 2's flyby of Uranus was more challenging to plan than the rest of the planets because the planet's tilt caused its moons to appear scattered, like targets on a bullseye. This unexpected layout demanded a significant shift in the mission plan, as the spacecraft would need to encounter all these celestial bodies nearly simultaneously. Long-range observations of the planet began on November 4, 1985, when signals took approximately 2.5 hours to reach Earth. Its closest approach to Uranus took place at 17:59 Universal Time on January 24, 1986, at a range of about 81,500 kilometers, or about 50,640 miles. Voyager 2's observations revealed intense wind speeds in Uranus's atmosphere, reaching up to 724 kilometers per hour or 450 miles per hour. The spacecraft also detected indications of a subsurface ocean of water, approximately 800 kilometers or 497 miles beneath the planet's cloud cover. The variability in thickness and opacity of Uranus's rings was noted, adding to the complexity of their structure. Much more interesting than most planets, Uranus was found to possess a magnetic field tilted at an angle of 55 degrees off-axis and off-center, orbiting the Sun like a rolling ball. This tilt leads to extreme seasons, with years-long winters when half of the planet is in continuous darkness and dramatic shifts in Uranus's cloud patterns. The unique tilt may result from a collision with a planet-sized object long ago. Additionally, the spacecraft detected two new rings, dark, narrow, thin bands of ice, rock, and dust with particles the size of a fist, expanding the known ring system to 11. Voyager 2's exploration of Uranus identified 10 new moons, creatively named after Shakespearean characters like Puck, Portia, Juliet, Cressida, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca. Voyager 2 took breathtaking pictures of Uranus's moons, including Miranda, Oberon, Ariel, Umbriel, and Titania. The encounter with Miranda was fascinating because Voyager came within 28,260 kilometers or 17,560 miles. The images revealed Miranda's varied surface, with diverse and seemingly random features, including deep canyons plunging 19 kilometers or 12 miles into its surface. In contrast, Uranus itself appeared relatively plain compared to its moons, showcasing the unique characteristics of this distant planet. Following the Uranus encounter, the spacecraft performed a single mid-course correction on February 14, 1986, the largest ever made by Voyager 2 to set it on a precise course to Neptune. Voyager 2 completed a remarkable 7 billion kilometer or 4.3 billion-mile journey to Neptune, reaching the planet on August 25, 1989, at 3:56 Universal Time. During this historic encounter, the spacecraft flew within 4,796 kilometers or 2,980 miles over Neptune's cloud tops, marking the closest of its 4 flybys and becoming the first human-made object to pass by the planet. Despite the vast distance traveled, all 11 of Voyager 2's instruments were operational during this pivotal moment. Detailed images captured by Voyager 2 unveiled key features within Neptune's clouds, such as the Lesser Dark Spot, Great Dark Spot, Scooter, and 4 additional rings around Neptune. The planet exhibited more activity than previously thought, with winds reaching 680 miles per hour or 1,100 kilometers per hour. Hydrogen was revealed as the predominant atmospheric element, while methane contributed to Neptune's distinctive blue hue. Notable discoveries made during the encounter included the identification of 6 new moons called Proteus, Larissa, Despina, Galatea, Thalassa, and Naiad. To approach Neptune's largest moon, Triton Voyager 2 flew over Neptune's north pole and descended towards Triton before continuing its trajectory out of the solar system. The spacecraft also imaged 2/3 of Triton, showcasing its frigid surface and a nitrogen ice volcano. The southern hemisphere of Triton displayed a unique, pockmarked terrain, reminiscent of a cantaloupe. And then Neptune's most distant moon, Triton. It also had geysers, and that was a complete surprise, so far from the sun, so cold, and yet these little tiny black wisps coming up from the surface of Triton. These were erupting geysers shooting out material miles into space. In other places, there were lava-like flows of ice, all of it believed caused by volcanic processes underneath Triton's surface. A world at the very edge of the solar system frozen. We thought would be completely geologically dead, and it turns out to be geologically active. That was a great surprise. This Neptune flyby marked the conclusion of Voyager 2's extraordinary 12-year planetary exploration, effectively fulfilling the envisioned grand tour of the solar system by reaching its intended targets and providing invaluable scientific insights.
In fact, the Voyager 1 cameras went off in 1990, but before they did, on Valentine's Day, they took this wonderful portrait of the solar system with individual shots of planets, including a view of Earth.
As part of a series called the Family Portrait of the Solar System came the Pale Blue Dot. It is a renowned photograph of Earth, taken by NASA's Voyager 1 spacecraft on February 14, 1990, from approximately 3.7 billion miles, 6 billion kilometers from the Sun. This remarkable image portrays Earth as a minuscule dot amidst the vast expanse of space, serving as a poignant symbol of humanity's position in the universe. Captured using Voyager 1's narrow-angle camera, Earth appears as a tiny point of light, barely discernible even in the high-resolution image.
And you can see it looks like more than a dot, but it is in fact less than a pixel. You can see that it is slightly blue, and this is where we live, on a blue dot. On that blue dot, that's where everyone you know and everyone you ever heard of and every human being who ever lived out their lives. It's a very small stage in a great cosmic arena. Just speaking for myself, I think this perspective underscores our responsibility to preserve and cherish that blue dot, the only home we have.
Voyager 1 became the most distant human-made object in space on February 17, 1998, after it passed by Pioneer 10, the first human spacecraft to fly beyond all the planets in our solar system.
And then after 1989, we began what is now called the Voyager Interstellar mission. We were on a path we hoped to get to reach interstellar space while we still had power on the spacecraft to transmit the data back. The sun creates this huge bubble of plasma, ionized material, blows outward at 1 million miles per hour and creates a bubble. And inside the bubble, most of the material has come from our sun, and the magnetic field has come from our sun. Outside the bubble, most of the material comes from other stars that exploded 5, 10, 15 million years ago.
Voyager 1 crossed this boundary in December 2004, followed by Voyager 2 in August 2007. They went through various regions within the heliosphere, the vast bubble encompassing the sun, encountering distinct boundaries. These boundaries include the termination shock, where the solar wind abruptly slows due to pressure from the interstellar medium, a mixture of gas and dust between stars.
We have an instrument which measures the wind coming from the sun, and we saw that, in fact, there was no longer any measurable solar wind. We had left the bubble, basically.
Finally, Voyager 1 breached the heliopause on August 25, 2012, officially entering interstellar space. Voyager 2 replicated this feat on November 5, 2018. Despite their extended journeys, both spacecraft remain operational beyond the heliosphere, transmitting invaluable data to Earth.
Well, this just contributes to the number of discoveries that Voyager's been making, and this is one we'd hoped we would have the chance to do, and fortunately, the spacecraft were still operating when they reached interstellar space. It's really quite remarkable.
For about 46 years now, this spacecraft has consistently exchanged data with the DSN servers, giving valuable information about interstellar space. It is flying further and further away from our solar system.
Voyager changed our view of the solar system, really. I mean, we saw these active volcanic activity on Io. We saw the possibility of ocean on Europa. Just time after time, we were discovering things that we had not really even imagined some years before the Voyager mission. What makes it so exciting is that not only do we confirm what we thought we knew, but even better, it tells us where we didn't know that there was something to be discovered.
Voyager 1 is currently moving at 38,000 miles per hour and is about 23.5 billion kilometers or 14.6 billion miles from Earth. Voyager 2 moves at 34,391 miles per hour and is approximately 20.4 billion kilometers or 7 billion miles away. The Voyager missions have been instrumental in expanding our understanding of the solar system and interstellar space, providing crucial insights into the interactions between our sun and the surrounding environment. Thanks for joining us on this cosmic adventure. What did you find fascinating about the Voyager's mission? Are there any other space exploration topics you'd like us to explore next? Drop your thoughts in the comments below, and remember to hit that like button, subscribe, and click the bell notification for more exciting content. Together, let's keep unraveling the mysteries of the universe. Until next time, keep looking up in our sun and the surrounding environment. Thanks for joining us on this cosmic adventure. What did you find fascinating about the Voyager's mission? Are there any other space exploration topics you'd like us to explore next? Drop your thoughts in the comments below, and remember to hit that like button, subscribe, and click the bell notification for more exciting content. Together, let's keep unraveling the mysteries of the universe. Until next time, keep looking up